Alright, in this video part 2, what we're going to work on reference angles of Quiz 5.1E. Alright, to do the reference angle, you have to know what quadrant your angle is. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay? And you need to find the angle that falls into one of these quadrants. So if your angle is bigger than 360, you're going to have to subtract to get it between 0 and 360. If it's negative, you'll have to add to get it in between here. If you're not in degrees, if they give it to you in radians, then you'll have to convert to degrees so that you can place it in a quadrant. Once you place it in a quadrant, you apply this formula, one of these 4 formulas, and then you get your answer. Alright, let's do example number 1. Alright, we want to find the reference angle of theta equals -45. Now this is clearly not between 0 and 360. So what quadrant is it? Right. So what we're going to do is we're going to add 360 to this number. So -45 plus 360 equals 315. Right. 315 falls, remember this is 0, this is 90, this is 180, and this is 270. So it falls here in the 4th quadrant. Okay, so that means we have to do 360 minus 315, and then we're going to get 45. There you go. This is the reference angle. Got it? There we go. Find the reference angle of theta equals 2 pi over 3. Well, the question is, what quadrant is that in? What's in radians, it's really hard for us to know, so the first thing we should do is we should change it into degrees. And we do that by multiplying by 180 over pi. This cancels and we do 2 times 180 divided by 3. Right, we get 120 degrees. 120 falls in the 2nd quadrant, right? Remember, you should know those measurements. So it's going to be in the 2nd quadrant. That means we have to apply this formula. 180 minus theta. That's going to be... Oh, wait. Yes, this is the reference angle in degrees. Okay. We have to get this in radians because the initial question was in radians. So we have to convert 60 degrees back into radians, right? And you get pi thirds. This is the reference angle in radians. Okay? So this would be the answer that you would report.